All right, so the good news is I fixed, or at least I, knock on wood, hope I fixed the problem from Friday. If you looked at the video was there. It looked fantastic. There was just no sound to it. So this one should have sound. I checked it right before I got started, and I'll double check it at the end. But one other thing I want to go ahead and emphasize, just a couple things. How many people have had the opportunity to look at the websites? Okay, especially if you're absent, please take a look at that website. So here, Math Studies, and just in case, is there anybody out there who still needs that code to get there? 1807A2, lowercase. Okay, hope you got it. We're good to go. Okay. 1807A2, and I do have it up on the board over here, the whiteboard right here. But I do want to go ahead and point out some things that I've already posted for you. A lot of information crucial to your internal assessment, which is 20% of your IB grade. So if you come all the way down here to last week's, okay, the 14th to the 16th, a lot of information, including the rubric. If you go past the outline, okay, tells you exactly for each criteria how many points. There's some ideas there that could help you potentially come up with a project idea if you're stuck, if you're stuck, or if you want to come talk to me. So much information here, and like I said, hopefully, maybe you're just taking one or two of those a night. You don't have to definitely do it all at once. I mean, who wouldn't want to? But kind of spread it out so you don't get too overwhelmed. I know you got other things going on. And then we're into this current week right here. Just want to go ahead and emphasize, you're always going to be told specific things, upcoming items, things of that nature. In fact, number one, it says you have a frequency histogram box and whisker plot quiz on when? Thursday the 22nd. So this Thursday, we are already going to have our first quiz over the material we start today. Okay, in fact, I've already got it listed that the homework assignment is going to be due on Wednesday, and I do need to get that to you before you leave, so someone don't let me forget. Let's see, also, we're going to start focus activities. If not tomorrow, then definitely by Wednesday. If you're one of my previous students, you already know what that means. If you don't, we will get that taken care of. Just kind of hold tight. Number 3 is a big one. What's coming up on Thursday the 29th? Your first exam, okay, right before progress reports. So next Thursday is already going to be your first exam. So anything starting today all the way through next Thursday, I mean, it's fair game. We're going to be looking at a lot of stat strategies, okay, the first 6 weeks. All right. Any questions about the websites? Has anybody read through any of the papers I uploaded? Many examples on the IA, and I got other ones if you want to look at them too. Okay, but so much information right here. If you're looking for something, or if you're absent, you want to see what's going on. Perfect. Okay, well, let's take a look at what we got here. Okay, our first topic: frequency tables. All right. Okay, so what is statistics? It's the science of getting facts from figures. It's going to involve the collection, organization, and analysis of sets of observations called data. The data represents individual observations to which we can assign some numerical value or categorize in some way the identifies an attribute. The set from which the data is collected is known as the population. The population can be an infinite or a finite set. However, the data collected will be a subset of this population. We refer to it as the sample. We talked about that several times last week. The process of gathering the data is known as sampling. All right, so once we have our sample, we use characteristics of the sample to draw conclusions about the population. This is known as making statistical inferences. And this is a huge difference here. A lot of people are kind of muddy on the difference between the two. They're not identical. Statistical inferences and descriptive statistics. Okay. What we do here, if we simply take the data and we go ahead and visualize it in some kind of chart or a table, that's simply what we call descriptive statistics. But if we actually take some strategy and apply those mathematical strategies to the data, that's what we refer to as statistical inferences, because based on what we see, well, then we go ahead and make our own conclusions. Okay. Hopefully the data is going to support that, but is it possible that your data could actually turn out to be the opposite of what you thought? And is that perfectly fine for your IA? Absolutely, absolutely. You can either choose to work that in or possibly tweak your IA topic. So basically, this encompasses what you're going to be doing on your IA. You're going to come up with some kind of theme, okay, some kind of topic, and you're going to decide from what population is it going to be best that I get my data. Okay, so whether you create your own survey or if you go to the internet or you just go ahead and decide to collect it yourself, through some way you're going to create a sampling process. You're going to get your sample, okay, the data. Then what you're going to go ahead and do, possibly you can go ahead and put it in a graph or something, but you're going to want to put some kind of mathematical strategy into it. It could even be something as simple as measures of central tendency, which we are going to talk about in this first lesson. I'm talking about mean, median, and mode. Okay, maybe you think that using standard deviation would benefit your paper in some way. Maybe you think that doing a statistical test like chi-squared test for independence. That's a statistical strategy that we're actually going to spend an entire week on because it's so long. Very useful strategy though. But in some way, you're going to apply these strategies to the data and you're going to come up with your analysis. What is this telling me now? And that's basically the framework of your paper. Okay, so you can either go ahead and say, okay, well, the data is consistent with what my IA topic is, or I was surprised that the data actually showed this instead of what I was thinking. Okay, remember the IA is completely yours to deal with. Okay, oh my goodness, I forgot to erase all these for previews. Pay no attention to the man behind the curtain. There we go. You guys get that reference, right? There we go. Yay. I did it so fast you didn't see it. Okay. All right, let's look at classifications of data. So what? That's right, exactly. What'd you see? Nothing. All right, numerical data. It's made up of observations that are quantitative and have a numerical value associated with them. Okay, so something you can assign a number value to. Versus categorical data, that's made up of observations that are qualitative, sometimes known as nominal data. Like if you're talking about car colors, okay, well you categorize them as brown, blue, red, or even by the type of vehicle. Okay, it's not a numerical value assignment. Okay, so let's come on down here. We got 3 examples. It says classify the data as numerical or categorical. It's numerical if it's a way where I can assign an actual number value to it, or otherwise it's going to be nominal. We call it categorical. So let's see, A, the breed of a dog. Yeah, that's going to be categorical. Okay. Really not thinking about how I can assign a number value to the breed of a dog. I mean, I can go ahead and say Border Collie's 1, but that doesn't really do anything. Okay, B, the winning margin in a football game. Okay, that'd be numerical, yeah. All right. As we're going to see this year, the winning margin for the Cowboys is always going to be higher. I hope. I don't know, man. Still got to figure out what's going on with Ezekiel. He needs to show up. Anybody here a Cowboy fan? Okay. I don't know, man. It's been a long time since we've been to the bowl, but I still think it's going to be a while. But anyways, we got a good team. Yeah. All right, the hair color of a person. Numerical or categorical? That is definitely categorical. Okay. Now, measurable or countable. Continuous data, data that is measurable, like heights, weights, ages, etc., versus discrete data, data that is countable. Now, there's a difference between measurable and countable. Example, the number of IB students in PAHS, abbreviation don't need to worry about, the number of dogs at a kennel. The big difference between continuous and discrete is that continuous allows for a portion of a value. Okay? You can have decimals, like when we're talking about heights of an individual. Okay. Is it possible someone is 5 feet 8 inches tall? Can we go 5 feet 9 inches tall? Yeah. So is it possible to have any kind of height between the two? Yeah, that's exactly what we're talking about. Now, discrete does not allow for any portions. It's either got to be one whole unit or it's not. Okay. And like the examples we give here, you know, the number of dogs in the kennel. All right, so let's try these next 3 examples. Classify the data as continuous or discrete. So continuous does allow for a portion of a value. Discrete does not. Okay, so what do you think about the number of dogs in the city? Definitely discrete. Okay, I mean, I guess if you want to get morbid, you can have a percentage of a dog, but that's going to be pretty horrible. I guess for the dog, it'd be pretty rough. It's because it's a dog. He says rough. Get it? Okay. All right. The volume of water in a bathtub. So does it have to be like a exact number of gallons, or can you have a portion of a gallon? Yeah. So that'd be what? Continuous. What about the time to walk 2 miles? Definitely continuous. Okay. And the times are definitely going to vary for different people. Okay. All that kind of stuff. Good, good. So is that okay? Does anybody have any questions on some of those? Yes, ma'am. Both continuous and discrete. You're actually going to notice that if you, especially when it comes to functions, if you go ahead and start classifying data, it actually is possible. I'm not going to worry about getting into the too much in here because when you look at it from a certain point of view, some data will be classified as continuous, but say graphically it could be discrete. Okay. Now, I'm probably going to go by that on a person-by-person basis if I see something like that in their IA. Okay, but typically that doesn't come up too often. Okay, that's actually a good question, though. Good question. Now, here's just something to think about for your IA reflection. It's not something that I'm going to go ahead and write out, but just questions you can ask yourself as you're working through on your IA. How would you categorize the data that you're collecting for your internal assessment? Because one thing IB really does like is the vocabulary. They really like the student to sound as if they do know what it is they're talking about. So you want to be using those terms and phrases that we use in here. You want to be using the appropriate notation, all that stuff. Okay. All right. Well, let's get to an example. 30 children attended a library holiday program. Okay, their year levels at school were, okay, so we've got this whole set of data. In fact, how many total elements do we have here? We got 30. Okay, so if you go ahead and count up all the numbers, you got 30. That's what the frequency is. The frequency is going to tell you the number of a certain number of elements in a set of data. Let me show you, let me kind of show you what I mean by this. So look at this data right here. Okay, how many sixes do I have? Okay, would you guys agree there are 6? Okay, so the frequency of the element 6 is 6. It appears 6 times out of the 30 elements in the data. Okay, so what I want you to do is go ahead and take about the next 20 seconds, fill in the rest of that column for me. Find the frequency for the element 7. So how many times does 7 appear in that set of 30? Okay, what's the frequency for the element 8? And then we'll talk about the tally in just a second. Okay. So can anybody tell me how many 7s are there? There are 9. How many 8s? Oh, got some differences here. There are 8 8s. Okay, 9s. 4 10s, 2, and there should only be 1 11 out of the entire set. Okay? So a lot of times you're not going to be provided the entire set like we are here. You're just going to be given a frequency table like this. You're going to know these are your elements and this is the frequency. So if I wanted to go ahead and list the actual set, which you are more than welcome to do, well, I know there are 6 6s. So I'd go 1, 2, 3, 4, 5, 6. And then I know there are 9 7s. And then I would list that, and by the time I'm done, I should be writing out 30 numbers. Okay? That's what a frequency table does. It's going to tell you the number of a specific element in a set of data. Now, you don't see this a whole lot, but I'm going to go ahead and bring it up. A tally is going to provide the same information as a frequency. You just use little tally marks to indicate that. And you usually do them in groups of 5. So for example, there are 6 6s. So I'd go 1, 2, 3, 4, 5. You know the slash is the 5th one, and then 6. That's what you do with the tally. Okay. But typically a lot of people don't really grasp that, or not that they don't grasp it, they don't use that idea, I'll say, because if you can just write out the number and call it the frequency, you're good to go. Does anybody want me to go ahead and fill in the rest of those tally marks? No, we're good? Perfect. Okay. Now, relative frequency. The relative frequency is found by dividing the frequency by the total. In fact, what this is going to do, it's going to give you the percentage of that particular element. What percent it shows up in the data. So, for example, I know that 6s show up 6 times. So I'm going to say 6/30. Well, what's 6/30? Okay, there you go. We can go straight to the decimal. We know that's 1/5, so 0.2. No, that's perfectly fine. That's what I was going towards as a big picture. So I know that 20% of the data are 6s. Okay. All I did was take the frequency and divide by the total number of elements in the set. Okay, well, let's do the same thing for the rest of them. 9/30. Okay, so that's going to end up being 3/10. So that is 0.3. So the 9s make up, or excuse me, the 7s make up 30% of the data. Okay, and then we just continue all the way through. 8/30. It would be 4/15, and what's the decimal value? 4/15, so about point what? Let's round it to 2 decimal places for those who have a calculator. Amy says 0.27. Perfect. Okay, there we go. 9, then we have 4 of those. So 4/30 would be 2/15. What am I looking at there? Point what? 2 decimal places. Okay, 0.13. So we're looking at about 13% when it comes to the 9s. Okay, and then we got 2 10s and 1 11. So what would the 10 be? What percentage? This one we can actually go ahead and round either to 2 or 3 decimal places, which you'll get 0.067. That's what you should be getting, about 6.7% when you move the decimal. Okay. And then the other one, 1/30, well, that would just be what? 0.3? 0.03, there we go. So 0.03. Is everybody okay with how I got that? All right. Any questions on what a frequency table is? Okay. Now, you remember what I said a second ago, when you go ahead and take the data and you display it visually, that's what we call descriptive statistics. Well, I have a little chart right here that we're going to go ahead and visualize the data that we have. Okay, so the elements range from 6 to 11. So 6, 7, 8, 9, 10, 11. All right. And then over here, I've got my tick marks for the frequency. All right, so this is the frequency. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. And actually, I'm probably going to go ahead and count these by 2s, come to think of it, because I got to get all the way up to 11. So 2, 4, 6, 8, 10, 12. I'll go ahead and do that, because I don't have enough tick marks to get up to 11. Or, what's the highest I have to go on my frequency? Yeah, I was thinking about the elements. Oh, good Lord. 1, 2, 3, 4, 5, 6, 7, 8. Hey, welcome to math. Okay, so what was the frequency of the number 6? There were 6. Okay, so I'm going to go ahead and put a little marker out here. Just going to go ahead and create a little bar to indicate that the element 6 appears 6 times. Okay. What was the frequency of 7? 9. So this one I will go just a little higher. Probably right there is where I would say 9 is. Okay. And then we'll do this for the rest of them. 8 appeared 8 times. So maybe right about here. Okay. Then 9 appeared 4 times. So let me go straight across, maybe like right here. Then 10 appeared twice. Okay, right about here. And then 11 was only once. There we go. So I took the data and I displayed it visually. Okay. Now, what is this? Is this actually a bar graph or a histogram? Okay, it did tell us to construct a bar graph, so John Henry is absolutely correct. It's a bar graph, but what does that mean, histogram? What am I referring to? What kind of data is this? Would you classify it as discrete or continuous? I'd go ahead and say discrete. There are no decimal values. So the best way to go ahead and display the data is where the bars are not touching. But if it was continuous data, which would allow me to go ahead and take a portion of a value, then all the bars would be connected. I would have something that looks like this. That's a histogram. It's still made of your bars, but there's no space in between them. We're actually going to make one of those probably tomorrow. Okay. So let's answer some questions based on this. All right. We said we were using the discrete data. When is the modal year level of the children? What does it mean, modal year? Okay. What year or what element appeared the most? 7. So year 7. There we go. Describe the shape of the distribution. Are there any outliers? Now, we're going to talk about outliers tomorrow, but the shape of the distribution is if I were to go ahead and take the top of each of these bars here, and I were to go ahead and draw a smooth curve. Just like that. It is skewed, but can you tell me what way it's skewed? Is it left or right skewed? It's right skewed. We can also refer to this as a positive skew. So this is positive or right skewed. Okay. Now you're going to notice when we go through, there is a unit that we're going to be talking about with normal distribution. So you're going to be seeing graphs like this. And for each one, mean, median, and mode is going to have a specific relationship. So this is just something kind of off to the side. You're going to be able to see graphs that look like this. And you're going to be able to see graphs that look like that. Pretty much the reversal of the one we were just looking at. So if this one right here is a positive or a right skew, what do you think this bottom one's going to be called? This is going to be a negative or a left skew. Negative or left skew. Not right today. Okay. Now this one right here, this is what we call symmetrical or normal distribution. Okay. This is what we're going to be focusing on when we get to a particular lesson, and this is all IB is going to have us look at. We may see data that's going to be left or right skewed. We can make it normally distributed, but that's what we prefer to work with in IB. For this kind of case right here, this normal, this line right here, that represents where the mean, median, and mode are all the same value. The mean equals the median equals the mode. You don't have to remember that right now. We'll talk about it later. Okay.
What did you say that?
This is symmetrical. Symmetrical, or what we call normal distribution. And I'm going to go ahead and abbreviate that DIST. Okay. So that should be coming out probably like 2 or 3 weeks. We'll be spending a unit on that, talking about probability. Okay. What percentage of the children were in year 8 or below? Okay, so I can either look over here, I can look at the table, year 8 or below, or just look at the bar graph that I created. Okay, so how many students are we talking about? 23. Where'd you get the 23? Yeah, we're looking at the number of elements for those particular years. So I added those up, that gave me 23, and I'm going to go ahead and take a ratio with 23 out of 30. And where did the 30 come from? That came from the total. Okay, all the elements in the set. So somebody help me out. What is 23/30th as a decimal? And let's go ahead and round it to 1 decimal place. 0.8, okay. I guess I should have been a little more specific. I was thinking 76.7, but 0.8, you're absolutely right. Okay. When I said 1 decimal place, I was thinking about it being the percentage. So that was my fault for that miscommunication. Okay. What percentage of the children were above year 9? Okay, well, let's see here. Now, above your 9, now, how many children am I talking about? Only 3. It says above your 9. See, this one's not including it. So 3/30. Okay. 3/30, which is just 1/10. Ooh, got close. It was almost 2/10 in here. 2/10. It's a math fraction. Okay. So that's going to be 30%, or you can say 0.3. Okay. All right. Questions? Hey. Oh, I'm just checking to make sure you're right. Yeah. See, because I was thinking about the 30 from the 3. Yeah. And with that, it's a perfect time to stop. Yay. Yes, I'm going to go ahead and give you the homework. One thing I do need, please bring your calculators back up to the front. Go ahead and put that in the charging stations. Let me shut this down.